All right, page 3, another great photo from the magazine. Just really cool to see these cars. All right, look back at the graph on the last page. How long did it take each car to get to 100? So now we're trying to figure out 100. Again, let's go with the Audi. So how long did it take for the Audi to get to 100 miles per hour? Well, the Audi's right here. The red looks like it took 6.5 seconds. Okay, so 6.5 seconds goes here. And again, we're going to put it in a point, a coordinate, because the output is 100, and we're going to need that output. We're going to need that Y value in order to do our calculations. All right, Mercedes was the blue. Okay, so the blue is right here, and it's kind of off the graph. So I sort of ran out of room here. Okay, but it was 7.4. So 7.25 would be the first, and then it doesn't quite get another box over. It's like right before that, so it's going to be a 7.4. Okay, so 7.4. Should have put second. You got to put an S there to talk about seconds. Okay, and that means our point is 7.4, and again 100. So the Y values are the same here because that's how we're comparing. If you use the same Y values, then you can compare how the rates of change, compare which one is a faster rate of change. All right, last one, BMW. So let's find where the BMW is on the map or on the graph. It's up here. There it is. And it looks like, remember, these are 0.25 each of them, right? Think of it as like 25 cents. So 25 cents, 50 cents, 75 cents, $1, $1.25, $1.50, $1.75, $2. Okay, so this is $6, $6.25, and then a little bit past it. So we'll say $6.30, all right, or 6.3. All right, so Mercedes, or sorry, BMW was 6.3 seconds, and that gives us a coordinate of 6.3 comma 100. Okay, and we could have labeled it on the graph too if we had some time, but we're going to move on because I don't want to waste too much time doing graph stuff. So let's start diving into this. So we're going to use this data to determine which car accelerates the fastest from 60 miles per hour to 100 miles per hour. Acceleration is the average rate of change of a speed of an object. So how much the speed is changing over a certain amount of time. So the faster it is, the higher the acceleration. The slower it is, the slower the acceleration. Okay. So high acceleration means it's going faster, or it's speeding up quicker. Okay. The function rule we use for acceleration is this. Doesn't this look very similar to what we had up top? Okay. A bar, which is this is what's called A bar. That's kind of a physics term. So if you ever get into physics someday, A with a bar over it means acceleration. Okay. But another thing for it can be M, because again, we're just talking about the slope of these graphs. Okay. Acceleration is just a slope. Delta S, well, S was speed. Okay. And speed was our Y value. Didn't we say delta Y was on top? So there you go. This is our Y's. All right. The S is the speed, and speed is Y's. So these are the Y values. T is time, and time was our X value on our graph. So again, that's our X. So again, this is just another way to write the formula we already talked about, which is that slope, or the rate of change, or the acceleration, is delta Y over delta X. Okay. So this is not something new. We're just kind of putting it into a new perspective for us. Okay, we're talking about it in terms of functions, but we're sort of bringing it back from something we worked on at the beginning of the year, which is just slope, a slope of graph. All right, the slope is kind of the direction, right? How do we get from one point to the next? So the slope tells us how steep a line is. All right, and now we're learning, it also tells us the average rate of change, the amount that the values are changing and how quickly they are changing. Okay, so let's find the acceleration of the Audi RS7 from 60 to 100. And the way we're going to do that is we're going to use the acceleration formula, okay? So we're going to do A is equal to, and you don't have to do A bar. I don't know if they have that on here. Probably not. I'm not even worried about it. All right, we'll just use A. All right, so acceleration is equal to, it's always good to put the formula first. So delta y over delta x. And I hate how it just hides it like that. Sometimes you can, if you want to put this over on this side, it might be easier. Okay. Okay, so delta y over delta x. What does that mean? That means we got to take our y values from our points and put them into the formula. All right, so it's going to be the y values subtracted, because remember, change. If we're doing average rate of change, then we are subtracting. All right, so we take the y values and we subtract them, and we take the x values and we subtract them from our 2 points. All right, so let's find what the points were for Audi. The first point for Audi was 2.7 and 60. I'm going to bring that down here for us so we have it. 2.7, 60. And then the second one here was right here, 6.5 and 100. So 6.5. All right, so there's our 2 points. Okay, remind ourselves the first one is the x, second one is the y, x, y. Okay. All right, all that's left to do is just to plug this into the formula. So it doesn't matter which order you do, but you have to be consistent. So if you're going to start with the second point and do the 6.5, or sorry, do the 100 minus the 60, then you have to start with 6.5 and do it minus 2.7. Okay. If you start with the second point first, you'll get positive answers, and then you don't have to worry about negatives. But again, it really doesn't matter. So the top is going to be the 2 y values subtracted together. So that's 100 minus 60. And then the 2 x values subtracted. So that's 6.5 minus 2.7. Okay. This looks complicated, but basically you're just going to do each one separately. So what's 100 minus 60? That should be 40. Okay, and 6.5 minus 2.7, I don't know that off the top of my head, so let's check the Desmos. Okay, 6.5 minus 2.7, that gives me 3.8. Okay, so this is a 3.8. And then I'm going to simplify this fraction by just doing the division in my calculator. So it's 40 divided by 3.8. And I'm not going to get a nice, easy number here. We're going to have to round. So let's round to the nearest hundredth, which means I got to look at the thousandths place. That's the one that's next to the hundredth to the right. This 6 tells me I need to bump up, so that 2 becomes a 3. So I've got 10.53. And what are the units for this? That's important because we're talking about word problems here, right? And units are important in word problems. So what does this mean? This means Audi accelerates at 10.53 miles per hour per second. Okay, so acceleration, the units are miles per hour per second, meaning the speed per second. Okay, so that's how fast this Audi accelerated from 60 to 100. All right. On the next page, you're going to figure out the other 2, and then you're going to really see which one is the fastest. So I'll see you on the next page.